This is a physics problem dealing with rising objects and what is required for them to meet. Difficulty is between medium and hard. Okay, so we have two objects A and B. Okay, B has initial position of y1 equal to 3 meters and is rising with a constant velocity of 1.2 meters per second. Object A is at y0, ground level, okay, and will be given an initial velocity, okay? Now the question is, what is the minimum initial velocity required for them to meet, okay? And we don't know where that will be, okay? So we don't know our initial velocity and we don't know our final position where they will meet. Okay, so first thing we're going to do is we're going to write down everything that we know, okay? So we have the initial position of object B is 3 meters. The constant velocity of object B is denoted by the average velocity subscript 2 equal to 1.2 meters per second, okay? The initial velocity of object A is unknown, and the final position where these objects will meet is also unknown. Okay, so writing the displacement equations for object B is going to use the average velocity, okay, since it has constant velocity. Okay, so writing that out gives that. Object A, we have this displacement equation, okay. Now they're both going to meet at position y2, okay. So now setting A and B equal to each other, right, y2 equal to y2, we have this equation, okay. Now what we want to do is we want to get all of our variables and values on one side, okay, and set it equal to 0, okay. So we have that, so we've done, okay. Now we have here a quadratic equation. However, we have two unknowns, okay. Initial velocity is unknown and our time is unknown. Now we know from the question that we want to find the minimum initial velocity, right? So our minimum initial velocity means that object A is going to have a final velocity equal to 0, right? It's going to be its maximum height, okay? Because it's only going to reach its maximum height and it's going to top out and it's going to have 0 velocity right at the point where they meet, okay? That gives us this equation, okay? Remember? So VF equal to 0, rewriting that. Plugging in negative 9.81 for A, right? We have negative and negative is equal to positive, dividing by G, that gives us that, right? So our time is positive, okay? So plugging that in for time, we get this equation, okay? Of course, equal to 0. Now rewriting it again, we have this, okay? Now, remember, this A is negative, okay? VO over G is positive, but A is negative, okay? So we have this, okay? Of course, it's equal to 0. Simplifying terms, right? Okay. Rewriting it gives us this last equation, right? This is a quadratic equation, okay? See that? So plugging this in with the calculator and solving our quadratic equation for our unknown, which is our initial velocity, gives us two values for initial velocity, okay? If we're lucky, one of them will be positive, one of them will be negative. In this case, we're lucky. One of them is positive, one of them is negative. So obviously our negative value, we're just going to throw away, and we're going to keep our positive one, which is 8.965 meters per second to two significant figures is just 9.0 meters per second, okay? Now I'll leave you to do the check. You just plug in the values and find out what position they meet at. Okay. So yeah, that's it. If you liked it, give it a thumbs up. If you have any questions, feel free to leave a comment. Thank you.